I know.
They can pitch in
Okay, we're live.
$2.
What is it? November 30th, right? All right, so modeling rational functions. Rational just means a fraction. Anytime you see the word rational, it means fraction. So I'm hoping when I set all of my problems up, I'll have some type of fraction, okay? So the senior class wants to buy the principal a gift in thanks. The cost of the gift is $120 and there are 75 seniors willing to pitch in for the gift. What is the cost per student? Well, this is pretty easy, isn't it? We're just going to go, well, got $120. We're going to divide it up into 75 seniors. All right, I probably need a calculator to do this. And I'll divide. So I'll take my 120, divided by 75. $1.60 each. Okay, not too bad. I think they could all probably afford that, right? Right? Yeah. Sure. Now B. If additional students join into pay, write an expression to find the cost in terms of X. So I'm going to take my $120, right? And I'm going to divide it by my 75 students plus, we're going to add more kids in, right? But we don't know how many kids are going to join in, so let's just call it X. Thumbs up? Does that make sense? All right, that's not too bad, okay? And that's going to be then our cost per student, okay? So we can say C equals that. Well, now we can use our equation. So then if 12 new students join to help pay, so that's going to be, X is going to be 12, right? Then our cost per student is going to be 120 divided by my 75 plus my 12, right? Because that's my more students, 12 more students, which is 120 divided by, what's that, 87?
Yeah.
And if I go 120 divided by 87, about $1.38. Okay, so that's good. Price went down per kid. And then finally, if an, there's one of my mistakes, if an additional 10 students joined in on the cost, what is the price per student? So we get 10 more that jump in, so now X is going to equal 12 plus the 10, right? 10 more joined in. So then I'm going to have my cost per student is 120 divided by 75 plus my 12 plus my 10 more, which is 120 divided by 97, I believe. Man, let's use my calculator. Okay, and I get about $1.24 per kid. Okay, so I'll slow down for a second, let you catch up, but I don't think this is that hard. You guys agree? Pretty easy? And then a lot of your Mathia will do this. We'll do this whole kind of problem. And so most of Mathia is pretty easy. There's one problem that's kind of difficult on the Mathia, and I copied one just like it on the back of this. So give me thumbs up if you're ready to look at the back, okay? Yep. That was super easy. Agree? Okay, good. Okay. All right. Okay, number 2. So a train travels to a pickup station 300 miles away to pick up a load. It takes 6 hours to reach that station. Then the train travels at a constant rate of 45 miles per hour to the loading dock. So let's draw a picture of what's going on. I think a picture is always easier. Okay, so let's start here. So my train's going to start here. And it's going to go 300 miles to a pickup station, okay? Who knows what it's going to pick up? Coal, garbage, cows. No, hopefully not drugs. Okay, but then it's going to pick up a load, and then it's going to travel all the way to the loading dock. Maybe it's like where the boat is, right? Here's my loading dock, okay? So far, so good? Now we don't, here's something we don't know. We don't know the distance. We have no idea what the distance is. We know it's 300 miles from here to here, but the distance, we have no clue, all right? We do know, though, that it took 6 hours, so time-wise, it took 6 hours to go this far, right? So question number one's pretty easy. Okay. Question number one is, what is the average speed of the train for the, oh, nope, I'm sorry. Oh, that's 2. That's 2. Let's do 2 real quick and we'll come back to 1. Let's do 2. What is the average speed of the train to the station? So it's 300 miles, 6 hours, right? So I know the distance, rate is distance, which is our rate, is equal to our 300 divided by 6, which is 50 miles per hour. Okay, so just from here to here, we're going 50 miles per hour. Does that make sense? 300 miles in 6 hours from here to here. Now that's the easy part of this. The hard part now gets to the idea that we have no idea how far this is, right? So we're going to try and write an equation for the entire trip. So what's the average speed of the total trip? So the total trip is all of this, right? We know this. The total distance in terms of x. We know that the total distance from start to loading dock is 300, because we got to go from here to here, right? It's got to be 300 plus this distance, which we don't know. We don't know. But we do know that distance is equal to rate times time, right? And we know the rate was 45 miles per hour. So we can say this distance then is going to be a 45t. Okay, that's where it gets tricky. Okay, we don't know how far it is, but we know if we travel 45 miles per hour, we're going to get there someday, sometime, if we knew the time, right? If we knew the time. Okay?
9.
So our total distance is going to be 300 plus our 45t. Distance to the pickup is 300 plus this distance, which we don't know. If we knew the time, we could figure it out, but we don't know the time, okay? Now, the time, the total time, then is going to be, well, 6 hours here plus some time. I don't know what it is. Call it x, okay? So it's going to be total time is going to be 6 plus x, or 6 plus t, okay? I guess we could use t. But we want it in terms of x, so I'm going to change my problem because it says in terms of x. So I'm going to change it real quick to 300 plus 45x and 6 plus x. And they'll ask for the same thing on the Mathia, okay? Where x is time, okay? All right, here we go. Let's see if I can summarize, okay? 6 hours to here, 6 hours to here, plus some other time, okay, right? 6 hours to here, plus some other time, right? 300 miles to here, plus some other distance. We don't know the distance, right? We don't know the distance, we don't know the time, okay? So if we want a rate for the total time, it's distance, which is 300 plus 45x over the time, which is 6 plus x. All right, that looks weird, but it is the distance of the whole trip. This is a distance because we know, let me highlight, 45t is a distance because distance is equal to rate times time. This is a distance, 45t. If we knew the time, we'd know the distance. If I knew the time, I would get a distance, right? Total time is 6 plus the time it takes to get from here to here. 6 hours plus the time to get from pickup to loading. How am I doing? It's a little weird, isn't it? Okay, I see one thumb up, okay? Now, Now that I have an equation, we can answer 3 and 4 pretty easily, okay? 3 and 4, we're just going to use our equation. So for 3, we know that actually it took 6 hours to go from here to here. So now, what is the average rate of the train over the entire trip if it takes 6 hours from the pickup? All right, so that means my x is 6. And I'm going to plug my 6 in for x. All right, so I'm going to go, okay, my answer is going to be 300 plus 45 times 6 divided by 6 plus 6, right? Hold on, let me get my calculator out. 300 plus 45 times 6. I get 570 divided by 12. And so then I'm just going to go 570 divided by 12. And I get about 47.5 miles per hour, because that's my rate, right? That's how fast the train is going if it took 6 hours to get there, okay? Now, if it takes 9 hours, that means it's farther away, correct? If it took 9 hours, that means it's farther away. If it's farther away, then the rate's probably going to be even slower because it, takes longer to get there, okay? So now this time we'll do the exact same thing. We know now that our x now is equal to 9, and I'll take it and plug it into my equation. So I'm going to go 300 plus my 45 times my 9 over my 6 plus my 9. Okay, that's calculator time. 300 plus 45 times 9. I get 705 over 15. And I get an answer of 47 miles per hour. Okay, that's all I have. I want you to do the Mathia, and then the homework after you're done with the Mathia is on page 394, 395, and I'll put it on the board, okay? Thumbs up. Now the Mathia, if you need help, go ahead and ask, okay? I did it last night.